70-740 Lesson 4, Implementing Server Storage. In this lesson, we're going to take another look at our simple volumes, how to create a mirror, what the difference between a striped volume and a spanned volume, as well as RAID, and we'll be discussing within that, of course, RAID 0. We'll also look at RAID 1 and RAID 5. We're going to be taking a look at implementing iSCSI, how we can use this to be able to access remote storage within our network. And we'll be also looking at implementing storage replica, among other things. And like everything else, here's your key terms that we'll be discussing throughout this lesson. So remember, a simple volume simply uses unused disk space. So let's take a look at that. Over here I have my server 3 running, and I'm going to go ahead and bring this disk 1 online. And it's a 32 gig drive just like the rest of these, and I'm going to I have to initialize it. We'll go ahead and use the GPT, the GUID partition table. And then I'm going to right click and I'm going to create a new simple volume, but I'm not going to use the entire disk. I'm going to use, let's say, 20 gigabytes of it. And we'll click next. We'll allow it to assign drive letter D. We're going to do our file system as NTFS. Understand you could select REFS or FAT32, but there's no reason to do FAT32, that's for sure. And we'll just we're going to stick with that new volume label. We'll do a quick format, and there it is. There's our disk and new volume disk D. Okay. Now, if we want to do a spanned volume creates what appears to be one single volume out of storage space that's unused. So the first thing I'm going to do is I can create part of this. I could use this for a spanned volume, what's left over in my disk 1. But we need to have more. If we're going to span, we span across disk, right? So I'm going to bring this disk 2 online. We'll go ahead and we'll initialize that. Same way. And now I'm going to right click and I'm going to say new spanned volume. We're going to click next. And it's already grabbed the unused space in that disk 1. I'm going to select disk 2 and add that as well. And now we're going to go ahead and I'm going to, you know what, I'm not even going to use all of it. I'm going to use another 20 gigabytes here. And we're going to click next, and we're going to allow it to assign drive letter E. We'll click next, and let's label this spanned so we can see the difference. And let's say do a quick format also, and finish. It's going to convert them into dynamic disks. We see our labeling change, and there it is. So from the perspective of File Explorer, if we look at this PC, there is a drive. There is a drive and there is a drive. However, from the perspective of our disk management, it's not complete drives. Part of disk 1 is drive D. Drive E spans the unused portion of disk 1, continuing into disk 2, but not even using the entire thing. Now, in a spanned disk, there's no redundancy. There's no fault tolerance. If either one of these two disks fail, drive E will fail and the data will be lost. All data will be lost. And the way that the data gets filled is it begins with the unused portion of this disk. So it will fill and then spill into the next disk. If this was spanned across 3 different disks, it would fill the first unused portion, the next unused portion, and then finally whatever other remaining unused portions. Spill and fill. No fault tolerance. One drive fails, everything that spanned volume is created with fails. So that is a spanned volume. And right here we see them talk about that. And you can use up to 32 disks to do that. But of course, you can't span one disk. A spanning is across multiple disks, so it has to be at least 2 disks. And it appears as a single drive letter. Now, let's go back over here and, oops, not hyper, let's go back over here and we're going to go ahead and we're going to delete that volume. And then I'm going to delete the drive D as well, because none of those drive D or drive E's had any type of fault tolerance, didn't have any increase in performance. Well, let's go back over to our lesson. So we talked about spanned volume. We showed the simple volume, of course. Well, a striped volume, which is RAID 0, does just what it says. It stripes data across. It writes data sequentially across all disks that are part of the stripe. Here again, it has to have at least 2 disks and can contain up to 32 disks in that striped volume. It writes the data in 64 kilobyte chunks. So the first 64 kilobytes goes to, in your illustration there, A1, the next one to B1. If there's 4 disks in this, it would go to C1, D1, and then the next to A2, B2, and so on and so forth. This has much higher performance because you can read and write from multiple disks at the same time. So very high performance. So this is something you might use for multimedia. But keep in mind, just like if a drive fails in the spanned volume, you lose everything. If a drive fails in a stripe, you lose everything. If you've got a 32 disk stripe and one of those 32 disk drives fail, you lose everything. The only solution to that would be to run backups. Of course, backups affect performance, and the main reason to use this stripe volume is for performance. Multimedia, a lot of times video, if you're doing video editing, a striped volume is a great way to have the performance to do that. So how do we get around that? Well, we could use a mirrored volume. Mirrored volume still has good performance, but it also has fault tolerance, because whatever gets written to the first disk gets written to the second disk. Only 2 disks. Mirrored volumes require only 2 disks. All right, let's take a look at that. How do we do that? We'll go back over to our VM. We can right click. We can say new mirrored volume. We click next. We select our second disk and add. We're going to assign drive letter D. Next, we'll give it a label of mirror. Oh, there we are. We'll do a quick format, otherwise it's going to take a while. Next, and finish. Convert to dynamic disk again. Remember, whenever we want to do any of these spanned or striped or mirrored or RAID file, they have to be dynamic. That we'll click yes. Should take just a moment. We should see it format and become available, and there it is. You'll notice that it shows both being the same. They are mirrors. If we go back over to our File Explorer, there is our 32 gig drive D. Whatever is written to this disk is copied to this one as well. They are mirrors of each other. Let's go ahead and we're going to go ahead and delete that volume. And for our next exercise, we're going to need a third disk. So we're going to bring disk 3 online and we will initialize it. And here again, we're going to use the GUID. Back over to our lesson. A RAID 5. So it's fault tolerant, and that data gets interleaved across a minimum of 3 disks. Very similar in the way of a striped volume, but we also write what's called parity. So it's essentially a striped disk with parity. If one of those 3 disks fail, The data contained on the failed disk can be rebuilt using the parity information that's stored on the disks in the rest of the volume. So, a RAID 5 can absorb single disk failure and still be able to stay online and still be recoverable. You simply replace the failed disk and tell the RAID array to rebuild, and then you have your fault tolerance once more. Same process if you have a RAID 1, you have a disk fail, you replace the failed disk and you rebuild the array. So let's take a look at how we do that RAID 5. Here again, minimum of 3 disks. Doesn't matter how many disks you have. Here again, RAID 5, you can have up to 32 disks. You still can only have a single disk failure for it to stay online. Now, if we right click and go new RAID 5 volume, and remember we talked about this before, you can only have a RAID 5 volume. That's only an option that's given to you in Windows Server. Windows 10 does not have this. You can do all these other volumes in Windows 10, but not RAID 5. And keep in mind, these are all software storage options. This RAID 5 is being created as a software RAID. It's not hardware RAID. Hardware RAID is much more resilient, and for the most part, that's the way your servers are going to be built, with some type of disk controller that does that RAID for you. So it's a hardware-based solution. These are all software-based. If the Windows operating system fails, you probably are going to lose your volumes. Might be able to recover, maybe. Let's do it. RAID 5 volume. Next, we're going to select each one of the disks that we're going to add to it. There's our 3 disks, and you'll notice the total volume size. Each one of these disks is 32 gig. That's a total of 96 gigabytes. The amount of storage that's going to be available to us is just about 66 gigabytes. Your RAID 5 total storage is whatever the total amount of disks is minus the storage capacity of one of those disks. So if we have 5 1 terabyte disks, our available storage would be 4 terabytes. If we have 4 4 terabyte drives, the total storage is 16 gigabytes, but the available storage as a RAID 5 is 12 terabytes. We click Next. We're going to, here again, we'll allow it to sign drive letter D, and we're going to label this RAID 5. And perform a quick format. Click Next and Finish. Convert to dynamic. Should take just a few moments, and we'll see our RAID 5 created. And there it is. And it's syncing. It's going to take a few moments for it to sync and make it available. If we take a look over here, there's our RAID 5, and they're formatted just about 64 gigabytes. So a total of 90 plus gigabytes available in this amount of storage. Total storage minus the contents of one disk. That's where that parity comes in. Should be done here in just a moment. Once it's done, we'll go ahead and we'll delete that back to our lesson. So let's take a look at storage pools and storage spaces. This is a feature in Windows 2016, and it allows us to combine multiple disks into a single logical volume, and then we can mirror that to protect against one or more drive failures. The operating system will see this as one large drive. Keep in mind, these drives can be any capacity, and it can consist of a variety of different interfaces, and it could be SCSI, it could be USB, it could be SATA. And when we combine those drives, we turn them into a storage pool. We can then segment that into multiple storage spaces, which then can be formatted with a file system. Let's take a look at an example of that. We could have two physical drives, a 200 gig and a 300 gig, and we create a storage pool of a total of 500 gig. It appears as one bulk storage. We then could turn that around, and we could create simple volumes. We could create two-way mirrors. We could create three-way mirrors. Many different ways that we can do that. Now we can also use a concept called thin provisioning. With thin provisioning, you are able to create a storage space that's larger than the available capacity of the storage pool. Sounds bizarre, right? So what happens is, once you start to reach the capacity of the storage space, for in the example on your screen, you have a storage pool of 500 gigabytes, but you created a storage space that appears to be 1 terabyte, twice your actual storage pool. Well, as you begin to reach the capacity of the actual space, you can add more drives to the storage pool and increase it and make it so that it can continue to operate just as if it was a single drive, as shown as drive H in the example. In our textbook, they give us the example of going to control panel and then searching for storage spaces. Well, this is actually how you would do it in Windows 10. In Windows Server, we don't do it through control panel. You're going to do it through Server Manager. And this is that interface. Let's go back over to our dashboard. And we're going to select File and Storage Services. We're then going to select Storage Pools. We can see here are physical disks that are available to us. Let's create a new storage pool. We click Next, and there is our primordial pool. We're going to call this Storage Pool. We click Next. We're going to select all three of those drives. We select Next. We can see it's going to have a capacity of 96 gigabytes, the total capacity of the disks, and we click Create. Should take just a few moments there, and there it's done already. And there is our storage pool. From that, we can create smaller disks, or using the thin provisioning, a larger disk that's actually greater than the capacity that we have. It was just that simple. We can do the same exercise from PowerShell. Remember that those storage pools allow you to combine several smaller disks to create a larger disk. Now, if you start to run out of space, as we talked about, you can add additional disks to the server and expand the size of your storage pool. And here is that wizard that we were just looking at. The exact same steps. Now we can also have tiered storage. If you use different types, different architecture of disks, different types of speed, and you combine those into a single pool, you may not get the best throughput because you got a lot of different things going on there. So remember that when you create this pool, you should be using the same type of physical disk. So if they should all be SATA, they should all be SCSI, whatever they may be. They all be SSDs. However you're going to do it, make sure that that pool you create uses the same types of physical disk. You can combine hard disk drives, your traditional spinning drive, with solid state, and that's called tiered storage. This allows you to increase performance while minimizing costs. Remember, the SSDs are a lot more expensive than the traditional HDDs. So we always want faster disk space, We always want that fastest storage. So everybody wants the SSD, but you know what? Economically, it doesn't make a lot of sense. Tiered storage is a way that you can combine those two types of disks into one virtual disk and volume. Now, you can't remove storage tiers from a virtual disk after it's created. It requires fixed provisioning, so whatever's there is the size. So we can manually create those pools based on those types of disks. In addition, we can create storage tiers within the same storage pool. Now, remember that during the day, storage spaces creates a map of how often users and applications access each data block. There's an optimization task that runs at 1 a.m. and it moves the most frequently accessed data to the SSD tier. And it moves the less frequently accessed or cold data to the slower HDD tier. That's how it makes that data available in a faster way. So it only happens once per day. It runs that optimization task. So the next day, some data that's being accessed is going to be able to be accessed very quickly, while new data that might be getting accessed will still be down on that slower HDD tier. Let's take a look at iSCSI storage. Our servers typically aren't going to have a lot of storage themselves. We want to be able to create racks of servers. You're going to have file servers. You're going to have servers that are dedicated to doing nothing but your storage solution. They're going to provide shared storage. You're going to connect your server to the stored storage. There's two basic ways that we do that, through a NAS and through a SAN. A NAS is network attached storage, and it's file level. It's basically just file shares. We use SMB, server message block, or we use NFS, network file system. So it's basically just the same as if you create the exercises if you follow the exercises that we did, where you right click a folder and you say I want to share it, and you set the permissions. That's what you're doing with NAS. In a storage area network, we have a storage architecture, and it allows systems to attach to storage in the SAN. And as far as the server that's connecting to that storage knows, it appears as a drive to the server. It looks like it's a locally attached drive, but it's storage on a SAN that you're accessing. That's the difference between a NAS and a SAN. If the server that's connected to that storage fails, the storage is still there. The data is still there. They're going to be highly resilient. They're going to be high availability. Typically, your server is going to have, let's say, a RAID 1 mirror for its operating system. And all the other data that it accesses, that it makes available, is going to be through a NAS or through a SAN that it connects to. SANs usually have a higher level of RAID, such as like RAID 10, where you've got much more higher availability, higher performance. You've got redundant power supplies. You've got redundant network connections. You've got monitoring tools. SANs are very resilient. SANs are very expensive. That's why most smaller businesses will use a NAS. Larger businesses and enterprises always use SANs. When you're using a SAN, most of them use SCSI command for communication between servers and disk drives. What that does is, by using those SCSI commands, you can connect disks using copper or fiber optic cables. The two standards used in SANs are fiber channel and iSCSI. Notice the spelling of fiber channel. It's not F-I-B-E-R, it's F-I-B-R-E, fiber channel. They create what we call a fabric, and it's a network topology in which the devices are connected to each other through one or more data paths. So this allows multiple servers to access the SAN. And both of those two technologies, the fiber channel and the iSCSI, allow the SAN to be in a different rack in the server room, a separate room, or even a separate building. Of course, it all comes down to what is your acceptable level of performance in dealing with bandwidth and latency. Now, remember what a LUN is. A LUN is a logical unit number. LUN, logical unit number. It's a logical reference to a portion of a storage subsystem. It could be a disk, it could be part of a disk, an entire disk array, or part of an array. So it's a chunk of storage. When we configure a server to attach to a SAN, you configure the SAN to assign a LUN to a specific server. The LUN allows the administrator to break the SAN into manageable pieces. If the LUN is not mapped to a specific server, the server cannot see or access the LUN. Now, what's iSCSI? We keep throwing it around. Well, that's Internet Small Computer System Interface. It's a protocol that uses the TCP network, and it uses TCP port 3260. Be aware that unlike fiber channel, you use standard Ethernet cabling and switches to connect servers to the SAN. Now, understand that because you're connecting to the SAN over the network, you should have at minimum 2 network adapters on the server. You're going to use one of those for your standard network communications. You're going to configure the other one for your SAN communication. And probably at least 10 gigabits per second or more. So you separate your data channels. Regular network traffic on one, your SAN communication on another. Storage devices provided by iSCSI, they're often used as storage devices that contain sensitive or critical data. So you need to protect your iSCSI infrastructure. And you're going to use the concept of what we call defense in depth. Defense in depth has been around for many years. You're going to use policies, procedures, and awareness. And how do you do that? You do that through cybersecurity best practices, enforcement of strong password policies, strong administrator password policies for how you access those iSCSI storage devices, physical security, perimeter security, using network protection such as access lists and CHAP and VLANs and physical isolation. It says you may want to consider, but you're probably going to use IPsec as well. You need to keep your servers updated. This is all part of making sure that you've got the best profile that your servers are running under. You want to protect the data that's at rest. That's data that's being stored. So you're going to use encryption. Be aware of all these different methods that we use to create that defense in depth. You'll notice that it's all different types of defense. From managing our users through the policies and the procedures and the awareness, and implementing a physical security to protect the servers and a perimeter security to protect the network from outside attacks. Layers, defense in depth. In our lab, we'll be looking at configuring the iSCSI initiator. This is how we go about connecting. We have to have a target server. So you have an iSCSI initiator. That's the server that wants to connect. And you have an iSCSI target server. that the initiator will connect to. You can see right here, the iSCSI target server provides tools to create and manage iSCSI targets and virtual disks. That target server can provide application block storage, remote storage, diskless boots, and run in a failover cluster environment. So we can do this in a clustered environment where we not only have disk redundancy, but we can have entire servers fail and it still stay available. We then are going to illustrate in creating an iSCSI virtual disk in our lab, the way that we identify it. We also need to talk about MPIO, multipath I/O. If you have a single connection to your iSCSI storage device, the storage is available, but it's not highly available. In other words, if that single connection fails, it's a single point of failure. Your connection to your storage is gone. If a network connection or a switch fails, that server loses its access to the storage. You need to have high availability technologies. These servers need to stay connected. They need to stay up. They need to be able to provide those services that the server runs. So you're going to use high availability technology such as multiple connected session and multipath I/O. What it does is it enables multiple TCP/IP connections from the initiator to the target for the same session. If a failure occurs, commands get reassigned to another connection automatically. Now, the multi-connected session does have better failover recovery and better performance than multipath I/O. Remember that. You may see that as a test question. Be sure to understand how this all works. You can install multipath I/O as a feature. Remember, you've got roles, you've got features. Well, this is a feature. We can also configure the Internet Storage Name Service, the ISNS, and it's a protocol, and this is what we use to discover, manage, and configure iSCSI devices automatically on a TCP/IP network. It emulates fiber channel fabric services. And this gives us a consolidated configuration point for our entire storage network. It also is a feature, and here are the steps to do that. We can also use the DD, the Discovery Domain Service, and it allows the partitioning of storage nodes into what we call management groupings. Then they're also called discovery domains. Now, what are some of the iSCSI best practices? Well, you got to have at least 1 gigabit per second. That's the very minimum. Maybe 10 gigabit per second would be better. Make sure that if you're doing this, now we're doing this in lab environment, so we don't have this, but if you're doing this in a production environment, you need to design high availability. You need to have redundant adapters. You need to have multiple switches, multiple paths. You need to make sure that you're implementing that security strategy for that storage solution. Ensure required performance levels. Security, security, security. Most of what we do boils down to cybersecurity to keep our data safe, keep our data available, and keep our data confidential. Make sure that you're reviewing any best practices for the network devices and adapters that are prescribed by the vendors who produce those items. And also make sure that you review best practices for the specific applications that may be running, for example, Exchange Server and SQL Server. Let's talk about a converged network. What is a converged network? It's a single network infrastructure, and it handles storage, data, voice, video, cluster, and management traffic. Data center bridging, DCB, it's a suite of standards that's been designated by the IEEE, the Institute of Electrical and Electronics Engineers. And that's what it supports converged networks so that network traffic can get sufficient bandwidth allocation while maintaining reliability. So in other words, it it understands what's the most important traffic. For example, voice, you can't have any latency in your voice. It utilizes QoS, quality of service. Your hardware must support that for you to even be able to use it. You need converged network adapters. You need dedicated iSCSI HBAs, host bus adapters. It has some of the features: congestion notification, priority based flow control, enhanced transmission selection. And here are some of those PowerShell commandlets that we can use to implement this. What is a storage replica? Well, a storage replica offers both synchronous and asynchronous replication. Synchronous replication writes data to your primary and secondary sites at the same time. So your data always remains constant. Your data always remains current and the same between the sites. Asynchronous replication is what we call store and forward. So it first writes the data to your primary storage, and then once that's completed, it copies the data to the replica. This could happen in near real time or on a scheduled basis. If you're going to implement synchronous replication, it's more expensive. If there's a lot of latency between the systems, if they're two remote systems that you're using to synchronize your storage on, you're probably going to use asynchronous replication because of that latency between the systems. And here are some of those requirements for doing server-to-server replication. They both need to be joined to the domain, got to have two sets of storage, at least 1 gigabit per second, and so on. We can do a Struts cluster. It's a Hyper-V cluster, and here you can see the requirements for that. We can do a cluster-to-cluster replication. So in other words, building clusters of multiple servers where one cluster replicates the storage to another cluster. High availability. These are high availability solutions. And here is the storage replica. It's the simplest one to implement is the server-to-server replica. It's not suitable for branch office replication because remember, a branch office scenario is very low bandwidth, so there'd be a lot of latency. So you don't use that in a branch office scenario. To be able to do this, the file server service role needs to be installed. So while it is already installed, in fact, if we go over here and we look and we go over to manage, add roles and features, and we expand, we can see there's already things installed in the files and storage services. Right there, storage services installed, but none of these other things are installed. The target server is not. The VSS, data deduplication, the file server role. None of these other roles are installed. So we would need to add additional roles or features to be able to use some of these things. And here are those PowerShell commands to be able to implement a server-to-server replica. So in this lesson, we started out by looking at all the basic ways that we can create disk solutions on a server. We then took a look at storage spaces and how we can use that to create storage allocations on a server. We discussed iSCSI, the difference between a NAS and a SAN, or different types of server replicas, and also the iSCSI initiator and iSCSI target server. Make sure that you review this thoroughly and you will do just fine on your exam. Thank you for reviewing 70-740 Lesson 4.